Now, coming to the basic definition of DFA and NFA means small difference is there. Same both are same, but little bit variation is there. DFA definition is simply in the case of DFA from each and every state, per given input symbol, there should be how many transitions are there? Means there should be exactly one transition should be there. Means this meaning is that I will tell you with an example. See, there is a state called S1. Assume S1 is initial state. Assume that. And assume S2 as final state. And on S1, I apply an input symbol A. On S1, I apply input symbol A. I reached where which state means S2. Now the question is, can I give a input A, same input symbol A on S1 means like this is not accepted in the case of DFA. Why means from each and every state per given input symbol, there should be exactly how many transitions should be there means only one transition is accepted. And again, if you give like this is invalid. So like this are not accepted. There should be exactly for a given input symbol, you will give how many transitions? Only one transition. Now the question is, can I give like this on S1 by using input symbol B? Can I give like this? Means yes. So what is the input symbol applied on S1 means B. So on S1 by using input symbol I reach S2 means this is accepted. So like this from a given state for given input there should be how many transitions are there? There should be exactly one transition should be there. Now coming to NFA, same thing but little bit variation is from each and every state per given input symbol there may be how many transitions mean there may be 0, there may be 1, there may be greater than 1. This meaning is that on S1 I apply input symbol A and I reach which state? S2. And now the question is, can I give input symbol A on the same state means in the case of NFA these are accepted. So on this given state, you can give any number of input symbol, you can reach different states. That is valid in the case of NFA. That's why they told that for each and every state, per given input symbol, there may be 0 number of transitions, there may be 1 number of transitions, there may be greater than 1 number of transitions are accepted in the case of NFA. And all DFAs are NFAs only, and a special type of NFA is called as what? DFA. And let us consider some of the examples regarding the DFA. First one, construct minimal DFA that accepts all the strings of S and B's and that must include what? Epsilon symbol. So we have to construct DFA that accepts all the strings of S and B's, means we have it may accept any number of S and B's, but it should contain minimum string is what? Epsilon. I already told you what is an epsilon means. Epsilon is called as simply a null string. Null string of length means how much means 0. So it should contain epsilon and that should and remaining all are S and B's, any number of S and B's come okay for us. So minimum length string is epsilon means there should always initial state and final state is same. Including epsilon means if you must include epsilon, then initial state and final state is same. Then any number of A's and B's come, no problem for us. So like this is the simple basic diagram of DFA that accepts all the strings of A's and B's and it always including what? Epsilon. So how many states are there here means there is only one state, that is S1. How many states are there? Only S1 is the state. And how many input symbols are there? Only two symbols, A comma B. And what is the starting state means? S1. What is a final state means? S1. And what is a transition function means? On S1, if you apply A, it reaches to S1. On S1, if you apply B, it reaches S1. See, on S1, if you apply A, it is the same state. On S1, if you apply B, it is the same state. Like this is the 5-tuple representation of Q, sigma, delta, S, M. Now, coming to second question, Same thing, construct minimal DFA that accepts all the strings of S and B's and that should exclude epsilon. Means it should not contain epsilon. Epsilon should not be included. So epsilon is not included means remaining single length strings are accepted and double length strings are accepted and triple length strings are accepted and fourth length strings are accepted. Like this, any number of finite number of S and B's. So simple diagram for this one, S1, and this is the final state. You can give single A comma B means you can apply small a comma as input, you can reach the final state. After that, any number of A's and B's come, no problem for us. So this is the basic diagram of that always exclude epsilon. And coming to third question, construct minimal DFA that accepts all the strings of A's and B's where each string should start with A means starting symbol should be A. After that, any number of A's and any number of B's come valid for us. But if the starting symbol B, that this is not accepted. All right. So starting with A is okay for us, but starting with B is not accepted for us. So, for example, take this diagram like this on S1. If you apply S2, if you give small a input, this is valid for us. And after that, any number of A's and B's come, any problem for us means there is no problem restriction for us. But if on S1, if we apply B, this always goes to which state means dead state. So on S1, if we apply small b, it always switches to what? Like this, any number of A's and B's come, okay problem. Like this on S1A, it reaches to final state, and then any number of A's and B's, okay for us, problem, no problem for us. On S1, if you apply B, it always reaches to its state, dead state. How many states are there in diagram means? There are 3 states, S1, S2, dead state. So there contains exactly how many states? 3 states. Now coming to fourth question, same, construct minimal DFA that accepts all the strings of S and B's, where each string ends with B means ending symbol should be B there. Before that, any number of A's and any number of B's come, no problem for us. But it's always ends with what? B. So simple diagram is like this. Like the single B is accepted for us. At the end, any number of B's come, no problem for us. And before that, any number of A's come, no problem for us. And if I apply small a like this, BA, 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 no problem for us. Like this is the simple DFA diagram of that always ends with B. Now coming to fifth question, that should always start with A and end with B, and in between any number of A's and any number of B's comes, no problem. That means starting symbol should be A, ending symbol should be B, and in between any number of A's and B's come, no problem for us. So like this, see simple diagram on S1, S2, and final state is S3, like this, like this. Starting symbol A, ending symbol B, okay, and at the end any number of B's come, any problem for us? No problem for us. And here in between any number of A's come, any problem for us? No problem for us. And if I apply small a, any problem? A, B, like this, A, B, no problem for us. And the last thing, if on S1, if we apply B, it always reaches to which state means dead state. Means why means it should always start with A only, okay? Then after you can give any number of A's and B's, no problem. So it contains how many states? S1, S2, S3, dead state. Like this diagram contains 4 states. And the last one, where each string contains AB as the substring, means it always contains AB as a string. Before that, any number of A's and B's come, no problem for us. And at the end, any number of A's and B's come, no problem for us. So it always contains AB. Before that, any number of A's and B's come. After that, any number of A's and B's come, no problem for us. So simple diagram. like this. This is the diagram. And at the end, any number of A's and B's come, any problem for us? No problem for us. It always contains AB as a substring. At the end, any number of A's and B's come, no problem for us. And before that, any number of B's come, any problem for us? Means there is no problem. And in between, any number of A's come, any problem? No problem. Like this. This is the basic diagram of which contains AB as a substring.